Have you ever gazed at the night sky and wondered, how did it all begin? Where did the stars, the planets, the galaxies, everything come from? The answers lie in one of the most extraordinary theories in modern science, the Big Bang Theory. Join us as we unravel the origins of the universe, explain the evidence behind this groundbreaking idea, and dive into the mysteries that still remain. The Big Bang Theory, the birth of the universe, the science mates. What is the Big Bang? Before the Big Bang, the universe as we know it did not exist. There was no time, no space, no matter, only a singularity. The singularity. A singularity is a point where the laws of physics as we understand them completely break down. It's an incredibly dense and unimaginably hot state, holding all the energy and matter that would later form. Everything. The initial expand. Approximately 13.8 billion years ago, this singularity began to expand in an event we call the Big Bang. But this was not an explosion in space. It was the creation and the rapid expansion of space itself. Key stages of the Big Bang. In the very first moments after the Big Bang, the universe was unimaginably hot and dense. The fundamental forces of nature, gravity, electromagnetism, and nuclear forces, were united as one. 2. Inflation. In less than a fraction of a second, the universe expanded exponentially. This sudden expansion smoothed out irregularities and laid the foundation for the formation of galaxies. 3. The quark era. As the universe began to cool, quarks and gluons, the tiny building blocks of matter, started to form. These eventually combined to create protons and neutrons, the core of all atoms. 4. Recombination and light. 380,000 years after the Big Bang, atoms finally formed, allowing light to travel freely. This light is what we now observe as the cosmic microwave background radiation. Evidence supporting the Big Bang Theory. The Big Bang Theory is supported by compelling evidence gathered over decades of meticulous scientific research. Cosmic microwave background radiation, CMB. The CMB is the faint glow of radiation left over from the Big Bang, a phenomenon that provides a window into the early universe. Discovered by Arno Penzias and Robert Wilson in 1965, it's often referred to as the echo of the Big Bang. This radiation offers a snapshot of the universe when it was a mere 380,000 years old. Remarkably, the CMB is almost perfectly uniform, yet it contains tiny fluctuations, regions of slightly different densities in the primordial cosmos. These minute differences eventually grew into the vast galaxies and clusters we see today. Modern missions like COBE, WMAP, and Planck have mapped the CMB in stunning detail, confirming predictions made by the Big Bang Theory and solidifying it as a cornerstone of our understanding of the universe. Redshift and Hubble's law. In the 1920s, Edwin Hubble made a groundbreaking discovery. Distant galaxies are moving away from us. The farther a galaxy is, the faster it's receding. This phenomenon, known as redshift, is a direct indication of the universe's expansion. Redshift occurs because, as space expands, the light traveling through it stretches, shifting toward the red end of the spectrum. Hubble's observations not only confirmed the universe's expansion, but also gave scientists the means to estimate its age, an achievement that revolutionized our view of the cosmos. The abundance of light elements. The Big Bang Theory predicts the specific proportions of light elements, hydrogen, helium, and lithium, that formed in the universe's first few minutes through a process called nucleosynthesis. Observations of ancient stars and primordial gas clouds show these exact proportions aligning perfectly with theoretical predictions. This remarkable agreement is yet another testament to the validity of the Big Bang Theory. In every piece of evidence, from the faint whisper of the CMB to the breathtaking vastness of redshifted galaxies, we see the profound story of the universe's origins. Misconceptions about the Big Bang. It's not just a theory, it's a fascinating story, one that challenges everything we thought we knew about the universe. It wasn't an explosion. The Big Bang wasn't an explosion in space. It was the expansion of space itself. This might sound like a small detail, but it's a crucial distinction. An explosion, as we usually imagine, happens within a pre-existing space. But the Big Bang was entirely different. It created space and time. Mind-blowing, isn't it? Even more fascinating, there is no center to the universe. Every point is moving away from every other point as space itself stretches. What happened before the Big Bang? This is one of the most profound and mind-bending questions in all of science. Here's the thing. Since time began with the Big Bang, the very concept of before might not even apply. It's like asking, what's north of the North Pole? The question itself starts to break down. Still, scientists have explored tantalizing possibilities. Some theories, like quantum mechanics and string theory, hint at ideas like a cyclic universe, where the cosmos undergoes endless cycles of expansion and contraction, or quantum fluctuations that somehow gave rise to the Big Bang. But let's be clear, these ideas, as fascinating as they are, remain speculative for now. They push the boundaries of what we know, and perhaps what we can ever know. The fate of the universe. The Big Bang doesn't just tell us about the past, it also whispers tantalizing clues about the future. What will become of our universe? Will it expand forever, growing colder and emptier with time? Or could it reverse course, collapsing into a fiery Big Crunch? Perhaps it might even end in a dramatic Big Rip, where galaxies, stars, and even atoms are torn apart by the relentless force of expansion. The ultimate fate of the universe depends on profound factors, like the density of matter and the enigmatic influence of dark energy. Right now, the evidence suggests the universe will continue expanding indefinitely. But let's not get too comfortable. This is far from certain. The role of dark matter and dark energy. Dark matter and dark energy. These two invisible forces dominate our universe, making up a staggering 95% of its total composition. Yet they remain some of the greatest mysteries in science. Dark matter acts like a cosmic glue, holding galaxies together. Without it, galaxies would simply fall apart, scattered into the void. On the other hand, dark energy is even stranger. It seems to be accelerating the expansion of the universe, pushing galaxies farther and farther apart. Cracking the secrets of dark matter and dark energy could completely transform our understanding of the Big Bang and the cosmos itself. Just imagine what we could uncover. Multiverse theories. Here's a thought that will blow your mind. What if our universe isn't the only one? Some scientists propose that our universe is just one of countless others in a vast multiverse. If true, the Big Bang might be just one chapter in an infinite cosmic story. It could also explain why the laws of physics in our universe seem so finely tuned for life, because out of countless universes, this is the one where the conditions are just right. But here's the catch. Proving the existence of other universes is an almost unimaginable challenge. For now, the multiverse remains a fascinating idea, pushing the boundaries of our understanding and leaving us awestruck at the possibilities. The Big Bang Theory is the cornerstone of modern cosmology. It's backed by compelling evidence, like the faint glow of the CMB, the redshift of galaxies, and the abundance of light elements. Yet, for all it explains, it leaves us grappling with profound, awe-inspiring questions. What caused the Big Bang? What role do dark matter and dark energy play in shaping our universe? And perhaps the most mysterious of all, what lies beyond our universe? What do you think caused the Big Bang? Share your thoughts in the comments below. We'd love to hear your ideas. The Science Mates, exploring the universe one question at a time. If cosmic mysteries excite you, don't forget to like, share, and subscribe for more explorations of the unknown.